The next speaker is Cuneyt Altinoz. He received his industrial engineering BS from North Carolina State University, and he continued his MBA work at Georgia Tech, and then he's back at the NCSU for PhD in textile technology management. He just about has finished all his work. He also worked for IBM and Fibre Vision in the operations management area. His current research is centered around applying fuzzy, constraint-based decision system to support business processes. In other words, he's using typical industrial engineering tools for textile management. He has other interests in supply chain management, performance measurement, and decision-making processes in general. So his topic today, as you find here, is a fuzzy modeling approach to supplier selection.
Could be bigger, but can you read that? Everybody? All right. Well, thank you for having me here. Like Dr. Sa said, my name is Cuneyt Altinoz. You can't hear me? All right. Like Dr. Sa said, my name is Cuneyt Altinoz. I'm from North Carolina State University. Currently, I'm a postdoc. I have already finished my PhD, but I guess the bio didn't make that very clear. Today, I'm going to talk to you about a fuzzy approach to supply selection, and the word fuzzy there does not refer to our feelings about supply selection, but it refers to the particular methodology that we're going to be using. Here's one slide summary for you. So at the end of my 15 minutes today, if you remember nothing, this slide should give you a good overview of what you should have taken from this presentation. We start with the idea that supply selection in textiles and other industries is a very complex business process. And we need to support, by using decision support methodologies and software tools, we need to support this complex business process, but supporting expertise is difficult. And there are a lot of reasons why that is, and the least of which is not that expertise is very difficult to tie down and to formally capture what it is. So it becomes very difficult to actually develop tools that will work with expertise and make it a lot better. So what we have done is we have developed a model for supply selection in textiles. We have developed a process for the analysis, and then we have developed a software program that will bring all of these items together. And fuzzy logic, as I'm going to talk about in this presentation, is the enabling technology behind what we have done. And the conclusions that I'm going to present to you is that fuzzy logic for supporting expertise and for supporting supply selection in textiles, it does work, but it does have some limitations. So that's what we're going to talk about today. I'm going to start with some decision-making issues. These are the challenges and these are the problems that we're trying to overcome with what we're trying to do. Supply selection is complex, especially in the business world where we have to deal with a lot of problems, and not in the academic world. Supply selection involves missing or imprecise information. A lot of supply selection professionals have to work with...
Just slowly.
Okay, I'll go more slowly.
We are Egyptian.
All right. Supply selection is complicated. The business professionals in the supply selection area have to work with missing or imprecise information. When they are trying to evaluate suppliers, they do not always know everything properly, or they have some inappropriate information or inaccurate information, but they still have to make their decisions despite these factors. There are also very complicated trade-offs and preferences. Supply selection, just like any other complicated selection process, is a balancing act between trying to balance different priorities and different goals within the company. And increased demand on the supply selection professional means too many things to evaluate. What I mean here is that it used to be a long time ago that you could select suppliers based purely on their price and their quality, perhaps. And you could look at maybe a few other issues like their service or their reliability. But in the very competitive markets that we're in today, as the markets have become more global, a lot of additional factors need to be evaluated by the supply selection professionals in order to make sure they select the right suppliers. And this makes the whole overall supply selection process very complicated. The process still mostly relies on experts' opinions. The decision makers basically have this down as an art and not so much as a science. They do use several different options for helping them with their analysis, but in the end it is still an art and not so much of a science. Unless, of course, you're basing your analysis on purely logistics or cost analysis. And another problem that we have is experts that are in the companies trying to select these suppliers, they are usually not trained well enough to use complicated systems. For example, you could use several different analytical options such as, thank you, such as linear programming, etc., but these do require an in-depth training program, and most of the professionals in the textiles industry, as I have spoken to them, do not have the training academic background in order to carry these out. So what they need in order to support them in this complicated process is something that is more intuitive and something that is more easy to use, but still remains powerful for them. So what we would like to have is intelligent computer support for these people. We need a computer system that can understand the issues as we do. And when we talk about the issues, the computer system or the methodology that we're going to use to tackle the supply selection process needs to understand all the vagueness in the process, all the approximations that the people are doing, all the preferences, etc. So what we need is something, or methodology, that we could tell our desires and our requirements and our thinking process. And what we can expect is that this methodology, or the computer system that is developed based on that methodology, is going to evaluate the alternatives as a decision maker using his or her judgment would have. But since it's a formal methodology that is based on several different elements, it can do it with more detail than a regular human decision maker can. And it can provide a system of analysis and feedback, which is something that's totally missing from the day-to-day operations of these decision makers. And it can do it quicker, which means you can also do it for a lot more suppliers and a lot more factors. So what we have developed is a model that's based on rules. What we do is we write a set of rules that reflects the thinking process of the users. These rules will reflect the requirements that the users are under, the constraints that they have to work with, the policies that the company is using when they're selecting these suppliers, and the strategies that the company would like to have the decision makers, the supply selection people use. This is a fundamental, not specialized approach. One advantage is that the flexibility. You can write these rules in any way you like, so that you're not forcing a particular point of view on the problem, such as using logistics or cost. The disadvantage, of course, is that these methods are going to be too general if your particular interest is in logistics or control or something. So if you have a particular interest in reducing the lead time, then you might be better off using a system that is based purely on trying to minimize lead time. But if you have a general business approach and you have a lot of different goals in your mind when you're trying to select suppliers, then a more fundamental approach such as this one is more beneficial. And the best supplier, in the end, is the one that satisfies most of the rules to the most extent. Our model, I'm not going to go into a lot of detail on this since we have only 15 minutes, but you can see the details in the paper that we have presented, and it's in the CD that came with your bag. It's based on three concepts. First of all, the model uses a network of rules and not just simply a list of rules. A network of rules, also called a constraint network in industrial engineering, is a network that has rules that are interconnected with each other by the virtue of sharing some variables. So this concept of constraint networks is used when we actually try to put this into implementation and we try to compute with these rules. We also propose a rule taxonomy. This is intended to help the decision makers work with these rules and get the appropriate ones down to make sure that they do not miss any important requirements or any important rules when they're evaluating their suppliers. And finally, we have an idea of how the selection plan is supposed to work, what kind of rules are core to the business, and what kind of rules change over time. I would like to talk more about the rule structure. We started with the idea that we're going to write rules, and we're going to use these rules that have captured the criteria that the decision makers use, and we're going to use these rules in order to evaluate the suppliers. But writing these rules on a piece of paper is not enough. What we're trying to do is go from capturing the expertise of a decision maker into a mathematical realm where we can compute with these. So the first thing that we need to do is impose a structure on these rules, so we can then take them apart and compute with them. So the structure that we have wrote takes three parts. So we start with a particular attribute. So in a rule, for example, that talks about defects, you might have an idea, you might have an attribute such as a defect rate. Then you can select from several different operators. These come from regular mathematical operators as well as fuzzy operators. Then you pick something like, well, I would like the defect rate to be less than a certain number. And then you use a particular term to finish your rule. So your defect rate must be less than low, medium, or high. And then you pick, for example, low, and then that forms your rule. So what we have done is we have taken a sentence that a decision maker, a buyer, or a purchasing agent can use in his daily work to describe how he thinks, and we have broken that down. We can go further than this. We can take different rules and we can attach them together as well. So we can take the first rule, which is defect rate. For example, if you have something like defect rate is greater than low, we can pick a connector. We can say defect rate is greater than low implies that the warranties must be good. So what you see here is an example of what you would get if you interview the purchasing agent. So they might say, well, I will accept a company whose defect rate is greater than low, but they must also provide me with good warranties. So what we have done now is taken that thought and broken it apart into pieces, and then apart into attributes and operators and given it a particular structure. When we have this component breakdown, we can define them and store them separately. This makes it easy to define the terms and the rules, to update them and to modify them. In addition, so it makes the overall process go a lot smoother when we can separate these components out. So what we have now is a structure, but there's still words. And if you're going to turn this into a mathematical construct, we need to go further. The mathematical base is going to be provided by fuzzy logic. 5 minutes. Fuzzy logic provides the mathematical foundation. It transforms the model from the qualitative to the quantitative. And it allows us to express different preferences. A fuzzy rule-based system, the fuzzy sets will allow us, I'm not going to go into detail about fuzzy logic and what it does, and you can find that information in a lot of different books because it's been all around for a while, so let me just hit the highlights. Fuzzy sets will allow you to define expressiveness. You can show your preferences, you can actually use imprecise terms, such as saying, I want the supplier to be approximately 95% on time, if you like. And you can use hard to define attributes, such as good, average, etc. The fuzzy rules allow the user to work with the system intuitively. So what you end up with are linguistic rules. So what you don't go from the words on a piece of paper into numbers and X's and O's, they still remain as words, except our computer system can now work with them because of the fundamental approach that fuzzy logic brings. We also developed a decision tool that we call S3. Here are some screenshots. What the decision tool does is that it puts everything together. So when we decided that after going through all of these steps ourselves, we're going to develop a software program that guides the users, the purchasing agents and the buyers, in problem definition, and then it evaluates automatically and produces the results for you and gives you some feedback. Well, there are some limitations with our approach. It's not suitable for all problems, obviously. It is best when human expertise is necessary, imprecision and preferences are involved, and the existing mathematical models do not approximate well. Assigning consistent weights to the rules is difficult, but there are other methods that can help, such as the analytical hierarchy process. And a valid selection plan is particularly critical because the software tool and the approach is going to base its evaluation on the rules that you give it. There are also, of course, some additional benefits in using this approach. You can learn significantly about your own practice. You can ask yourself your question, do the rules that we have match with our strategies, or do we need additional rules when we evaluate our suppliers? You can check on your priorities. Do we really know what's important when we select our suppliers? Do we value more our cost base, or do we value the reliability or other issues? And this approach, since it's a formal structured approach, is going to improve your consistency so that all your buyers will be using the similar rules and definitions. And it is a vehicle for better communication, both internally, since it facilitates updating the information between functions, and externally, you can give feedback to suppliers in a very structured manner. And it can be used as a tool for tracking supply performance, which is not something that's done except for in companies that are really advanced in supplier management. And it can be used to capture the expertise of your buyers, so in case they leave the company, you still have a database that shows what kind of things they were looking at when they were selecting suppliers. And that is the end of my presentation. I will gladly take any questions that you may have. Anybody?
Questions? He speaks fast, so.
A lot of information to pass on to you, so.
Let me ask you a question.
Yes.
How do you improve your software by examining the past data of what you have done?
Well, this is what we did actually. We used our software to evaluate suppliers that professionals have already evaluated or already have an opinion on. So what we did is similar to past data. So after applying our rules to an existing supplier base, we can see if the software tool is actually selecting the suppliers that the buyers would have selected otherwise.
So what are the success and failure criteria in evaluating? Do you rank them, or do you qualify?
There are several ways that we do it. There are 3 ways that we do it. In the 2 ways, we do rank them according to a final score. And you expect that the good suppliers, of course, to outscore the bad suppliers. And we did pretty well there. In the final one, it's not so much of a scoring issue, but it's more of a, is this supplier satisfactory versus is this supplier not satisfactory approach, where you just push the 2 groups apart. And we did pretty well there. The challenge, of course, is to make sure that the decision makers appropriately define what they want, so that the tool can satisfy them in that way. So if they have not thought about what they want very clearly, and if they don't define it properly, then they do not get the suppliers that they would really like. So we have learned that one of the key issues, after going through a little exercise like this, that one of the key issues is that the decision makers need to think about what is it that they really want before they start using a tool like this.
Any questions? Well, thank you very much.